Welcome to video 10.6c, an inscribed angle in a semicircle. I'll start with the theorem and then I'll show you how it comes about. Here's the theorem. If an angle is inscribed in a semicircle, then that angle is a right angle. Here's a very easy way to show that. Let's just pick any point on the circle. I'll pick that point. Let's draw it like such. Well, that angle is inscribed in a semicircle. AB is the diameter, and I know that this semicircle is 180 degrees. And I know an inscribed angle is half of the intercepted arc, so what's half of 180? 90. Now I could draw that angle anywhere I want. I could have put the point over there. Again, it's inscribed in a semicircle. I still have 180 degrees here. So this inscribed angle, again, will be half of 180. It'll be 90. So wherever that vertex is, does not matter as long as it's inscribed in that semicircle. Okay, let's go over example 3. In circle O, BC is a diameter and the radius is 20.5 millimeters. Chord AC has a length of 40 millimeters. Find AB. Okay, let's draw a picture. All right, not a perfect circle. So that'll be O. It says BC is a diameter. All right, it says the radius is 20.5. So 20.5 there, 20.5 there. Of course, the diameter would be just that sum, which would be 41 if we need it later. Chord AC has a length of 40 millimeters. So if this is 41 and if it's 40, if I want to draw it somewhat to scale, kind of make it be a little bit longer. So I'll go something like this perhaps. And I'll call that point A. So that's 40, and it says to find AB. Oh, well, this angle is inscribed in a semicircle. So this is a right angle, and if I'm trying to find AB, I'll just call that X for now. I've got the Pythagorean Theorem. So once again, this is 41 down here. So the equation would be leg squared plus leg squared equals hypotenuse squared. Okay, so let's multiply that out. X squared plus 1600 equals, now let me show you some mental math that could be used for 41 squared. I could really make that be 40 plus 1 times 40 plus 1. Hopefully we're okay that 40 plus 1 is in fact 41, and 41 times 41 is 41 squared. Well, I could just simply FOIL this out. First times first, well, I know what that is, 1600. Outers plus 40, inners plus 40, lasts plus 1, so it's going to be 1681. Again, I could have done that quickly in my head, but I just wanted to show you what was going on in my brain. Okay, so now I can just say x squared equals 81, so x will be 9. I'll disregard the negative value, it can't have a negative side length. So x would be 9, and that's what the answer is. So AB equals 9. Of course, this is yet another Pythagorean triple. If it comes up a lot, you'll memorize it. Otherwise, you'll just do this. So just bonus, we now have the 9, 40, 41. And again, remember what I said before. Typically, Pythagorean triples have numbers that differ by 1 unit or 2. So that differs by 1. Okay, so here's a bonus application. We'll be doing this later in the construction unit. And this is where geometry could be used in real life. So let's suppose that we have a piece of wood, a circular piece of wood, and we want to drill a hole in the exact middle, maybe for an umbrella or something to go through it. It says use a Carpenter square to find the center of the circle. So a Carpenter square is nothing more than a piece of metal that's got a right angle. So let me show you how to do it. So all I'm going to do is put the vertex of the Carpenter square anywhere on the circle. And then I'm going to draw this side here and this side here. And then I know that this would be the diameter, because if that's a right angle, I know it's an inscribed angle through a semicircle, so I know that's the diameter. So right now I know that the center is somewhere along that diameter. I don't know exactly where, but watch what I can do. I can do it again in a different location. So I'll take my Carpenter square and now I'll put the vertex over there. And I will draw there, and I will draw there. So now I know that this is also a diameter. Well, if the black chord was a diameter, the blue chord is a diameter, and they both contain the center, that's how you can locate the center. So again, a bonus application of geometry used in real life. So there you have it, inscribed angles in semicircles in math and in life.